In this Grasshopper tutorial, I will continue where I left off and complete this function, which right now just creates random topography, and I will add color and trees. So the first thing I want to do is add something that I forgot last time, which is a seed. If you go to any random node, you'll see that there's a seed input, and if I plug in 44, for instance, you can tell that by changing the seed, we can scroll through different random outputs. So I'm going to want to plug this seed node, the seed number, into every single place where we use randomness. All right. And now if I delete the name here, you can see it adopts the name of whatever it's plugged into, which suits our needs perfectly. Just to make sure it works, we can scroll through all these random surfaces, and now it's time to add color. So what I'm going to want to do is attach a Rep node to the output here. Now Rep is a category that encompasses surfaces, and it also encompasses polysurfaces. So this is kind of a general category that you can use. And I'm going to drag this to the beginning, just as a way of indenting. This is not necessary, but it's a way of showing myself that this function does one thing, it creates the surface. Now I'm creating a new function to add color. First thing we want to do is add a bounding box, and then we'll deconstruct that box. Only thing is, we don't want to deconstruct this box and treat it as a box, because we want to find the edges of the box. Deconstructing it as a box only gives us the domain that this box takes up. But if we deconstruct this box but treating it as a Rep or a polysurface, then we can find all of its edges. So to scroll through these edges and see kind of which one's which, we can use the list item node, and by plugging in a number, for instance 2, we can view just the second item in this list. Now I'm actually going to turn off this viewing because I think it's kind of obscuring these edges. And you can see as I scroll through, it's highlighting different edges of the box. Edge 0 is right here, and I believe edge at index 4 is right there. So those are the two edges we want to keep. Now that we know we want edges at indexes 0 and 4, I can delete this number slider and expand this to show edges at indexes between 0 and 4. If I tween these curves that I've just extracted and I give them a range, I input a range of factors. Now you can see I've created a bunch of curves in between which represent the heights at which we want to divide this surface up into different colors. As you can see though, there's this weird distortion happening, and that's because these curves are facing different directions, and all I have to do is flip one curve in order to make this work properly. All right, and if I plug in the number of steps, for instance 12, now I can change the number of color divisions. And all we have to do is project these curves onto the surface using the simple project command and plugging in this Rep. All right, as you can see, that didn't work because we're projecting in the wrong direction. By default, we want to be projecting in the Y direction. So if I plug in a Y vector, you can see we now have these nice topography lines. If all you wanted to do is create topography lines, it'd be simple enough to use these. So this is kind of handy to know, but what we really want to do is use these lines to divide the surface in order to make color. So if I divide surface, split this surface using the surface split node, then I can plug in these curves and this surface. And now it's going to take my computer a moment to think. Now there's an issue. What did I do? I split this surface a bunch of different times using these curves. And because these curves are grafted, I have a bunch of surfaces that have been split into two pieces instead of one surface that's been split into a bunch of pieces. So if I flatten this, now I'm just splitting the surface once using a bunch of curves. All right, and I am going to preview all of this other stuff off, even this surface up here, to just keep what we've currently created. And to add color, I'm going to use a custom preview. Now comes the difficult part. How do we add a different hue to each of these different levels? Well, we're going to want to use HSL, which stands for hue, saturation, luminosity. And the hue is really just a way of scrolling through colors of the rainbow. So if I create a number slider from 0 to 1, oops. Sorry about that. Then you can see I can scroll through each of the colors of the rainbow and return back at the beginning. But that's not exactly what we want. What we want is to attribute an individual hue to each of these fragments. And we want to do that based on the height of each fragment. So how we can find the height of each fragment is by taking an area, and this area node gives you a centroid. And the height of the centroid is a good representation of the height of the fragment itself. So if we kind of map the z-coordinate of this center of each surface to a different color, that's how we can add color. So I want to deconstruct, or it's just called deconstruct, which is how you deconstruct a point. And we'll apply this to the centroid. And now we have just the z component of every point, of every surface in the same order as the surfaces. So we can use these z components to add hues. The only issue is if we plug this in directly, it's actually quite a cool pattern, but it's not mapping properly. We want to kind of shrink these numbers to fit into the space that we want them to fit into. And how we can do that is using remap numbers. And we'll remap all of these numbers from their bounds. So this bounds number finds kind of the domain or the space these numbers take up. And as you can see, these numbers range from 1.63 to 7.21. And if we plug this into the source and leave our target to be from 0 to 1, then all these numbers are squished from the space they exist in to fit in a space between 0 and 1, as you can see here. And if I plug that again into the hue, now we're kind of scrolling through the rainbow as we travel up the surface. Now we're not quite done because this still isn't the distribution of colors we want, so we can use a graph mapper node in order to really customize our distribution a little bit better. Right now there's no graph selected, and so there's no change, but if I go in here and select a Bezier graph, you can see I can sort of change the distribution of these colors. So what I'm going to want to do is make sure that the bottom starts at blue, right? So I'm going to drag the beginning of this to where the bottom is blue, and I'm going to want to drag the end to where green is. Let's see, green's around here, and now I can change the curve in between to change kind of the color distribution. So how does this work? Well, I have all these numbers between 0 and 1, and the first number is 0.5. So what happens is that 0.5 exists here on this x-axis, and it projects up onto this curve. And whatever height it hits the curve at is its new value. And as you can see, it starts at 0.5 and it projects up to about here, which is a height of about 4. And so the first number in the output is 0.38, which makes sense. So that's a good way of visualizing what this graph mapper does. Anyway, that is how you add color to the terrain. And stay tuned for the next video in which I will show how you can add a random generation of trees to the same terrain. Thank you for watching, and stay tuned for the next video.